The natural base E is going to be found in applications. And just like those others, we're going to start with, and we'll pretty much be limited to it in this class, compound interest. It also takes into consideration if your number of compoundings is infinite, you can use a variation of that growth function. And if it's an infinite number of compoundings, it means it is continuously compounded. So if you have something that is continuously compounded, you're going to use a separate equation, and the equation for compound interest there is going to be A equals P times e to the RT. Again, E represents that growth factor being taken, applied with a number of compoundings equal to infinity. The letters still mean the same thing, so A is the initial amount. I'm sorry, the ending amount. Okay, so it's the amount at time t. The p-value is your initial amount. Again, this is the amount that you started with, or at time 0. Okay, the r is the interest rate in terms of a decimal. And finally, t is the number of years, okay, or your time value. And so what I want to do is take a look at the problem that we looked at on the prior slide. What happens if our number of compoundings is infinity? If we have this continuously compounded, okay, how would this affect the overall value of this investment? And so see if you can use that equation, A equals P times e to the RT, and calculate the account value if $19,000 is invested at 4.7%, but it's compounded continuously. How much would that be worth after 8 years? If we plug in our values, 19,000 times our E value to the power of our rate, 0.047, times our number of years, 8. Hit enter. We calculate this to be 27,672.50.